Hello and welcome to another riveting trigonometry video. We are going to work on just becoming more comfortable with solving problems that look like this. If they just tell you to find the tangent of 5 pi over 4. First thing you should do when you see problems like 1, 2, or 3 is draw these three little things, okay? First, our common trig ratios chart. Second, sine chart. Third, our cosine and our sine curve. And these are going to be what we use in order to answer the question. So tangent of 5 pi over 4. The first thing I want to do is determine the sine. And I determine the sine by determining the quadrant that the angle is going to terminate in. So 5 pi over 4. Over 4 tells me that I am going to be counting in increments of pi over 4. So I have 0, 4 pi over 4, and then 8 pi over 4. And let's determine where 5 pi over 4 would terminate. As I rotate around the unit circle, 5 pi over 4 is going to end just a little past 4 pi over 4. So we're in quadrant 3. Tangent is positive. So my sine is going to be positive. Now let's determine the value. Again, the 4 is going to tell me what column to look at on my common trig ratios chart. And then I look for the trigonometric function that I'm doing, which is tangent. I see where they intersect, and that's going to be at 1. Pretty straightforward once you get the hang of these, okay? Let me try to just erase as carefully as possible. Okay. Let's do example number 2, the cosine of 7 pi over 3. So the denominator of 3 is going to tell me what I am counting in increments of. So I start at 0. I rewrite pi as 3 pi over 3. I rewrite 2 pi as 6 pi over 3. So now let's rotate around the unit circle. I'm going. Oh, shoot. I get all the way to 6 pi, but I'm looking for 7 pi over 3. So I have to go up back into the first quadrant. So my angle is terminating in the first quadrant where everybody's positive. So my sine is going to be positive. Now let's determine the value. I'm going to use my common trig ratios chart in order to determine the value. Pi over 3 tells me to look in this column, and then I'm looking for cosine. So I'm going to look in this row. And they intersect at 1/2. So I've got positive 1/2 as my answer for that guy. Alrighty, clipping along. This is great. Okay. Example number 3. Ooh, this is a little funky. It says 2 sine squared 5 pi over 6 minus the cosine of 4 pi over 3. So remember, when we're doing trig stuff, right, sine squared x is really this, okay? So let's rewrite him in a way that makes it like a little more obvious what we're trying to find. Okay, so all I'm really looking for is the sine of 5 pi over 6 and the cosine of 4 pi over 3. I could totally do that. Whatever I get for those inputs, I'm going to put the numbers in the parentheses. The trigonometric stuff is going to disappear because I got a number, I got a value, and then it'll be very easy to solve. So sine of 5 pi over 6. The 6 in the denominator tells me that I'm going to be counting by increments of pi over 6. So I start at 0, I do 6 pi over 6, and I end at 12 pi over 6, okay? 5 pi over 6 is going to end right about here in the second quadrant, okay? In the second quadrant, I have sine being positive. So I know that I'm going to be squaring some positive guy. So let's look on our common trig ratios chart in the column of pi over 6. What do we have for sine 1/2? So I'm going to be squaring a positive 1/2. Cool. And there's a 2 out front. Okay, now let's talk about the cosine of 4 pi over 3. Cosine of 4 pi over 3. This time I'm going to be counting in increments of pi over 3 because the denominator is a 3. I'm going to rewrite it as 0, 3 pi over 3, and 6 pi over 3. I rotate through past second quadrant, and I end up in the third quadrant. So tangent is positive, therefore cosine is going to be negative in the third quadrant. So I'm going to know that cosine is negative for this guy. So I've got a negative item. Let's find the value. I'm looking in the pi over 3 column. I'm looking for cosine. I'm going to be using 1/2. All of my trig has disappeared. I'm just working with numbers now. Incredible. So I've got 2 over 1 times 1/2 squared is going to be 1/4 minus a negative 1/2 gives me plus 1/2. This is going to reduce to 2/4, which is reduced to 1/2. 1/2 plus 1/2 is going to be 1. Okay. For example 4, it says the sine of 3 pi over 2. So we call these, whenever we're counting by pi over 2, 0, pi over 2, 2 pi over 2, 3 pi over 2, and 2 pi, or I guess 4 pi over 2. Let's rewrite it as 4 pi over 2. We call these the quadrantal ones. And if you'll notice, these are the exact angles whenever we just use a plain old unit circle, right? So if we went around the unit circle, we would have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, these are the quadrantal values. And if we know one thing, we know that x is cosine, x is cosine, y is sine, y is sine. So we can use these coordinate points that lie on the unit circle to answer any of these problems where they're asking us to count in increments of pi over 2. So the sine of 3 pi over 2, I just look at my unit circle picture, 3 pi over 2. The sine is going to be the y coordinate, so I've got negative 1. For number 5, he's a little tricky. We're going to rewrite him as the sine of pi over the cosine of pi. And now I just need to find the sine of pi and the cosine of pi. So I look on my unit circle. The sine of pi is going to be 0. The cosine of pi is the x coordinate. That's negative 1. 0 divided by negative 1 is just plain old 0. I hope these are getting easier for you.